and welcome to UniCourse. This afternoon we are looking at Unit 22, Electronic Circuits and Devices. And this is the final part. We're looking at assignment 4 and the hints and tips. And we're looking at some theory as well. So look at an overview and the slides we're going to be talking about. We're going to be looking at suitable devices and the parent circuits and identify the appropriate manufacturer's data sheets, insert relevant information from manufacturer's data sheets, and look at how we're going to do the testing as well of the circuits. We're going to look at examples of performing tests on a piece of electronic circuitry and recommendations of appropriate action, and look at how to analyze and compare the results which are obtained from a practical and a virtual test on the circuits you're going to use. So an overview. So the first one is a pass one. You're going to select suitable electronic devices or components and look at the manufacturing data sheets. Basically, you'll be researching manufacturing data sheets and identify a suitable battery to power a drone. Interpret relevant information from the manufacturer's data sheets. You just want to confirm that what sort of battery you've got. Basically, we're looking at the data from the first task, and then it'll allow you to identify the chosen battery. The next one we're looking at is performing tests on an electronic device, which is set out in the assignment. That will be done by using a circuit simulator and creating a circuit which you'll put into your assignment, and test to record the output frequency. And finally is by analyzing it. You're going to be looking at the actual hardware side using Breadboard, construct the circuit using an anti-collision flashing unit, and record and calculate the frequency using an oscilloscope. So let's start off with the first thing, data sheets. Most of you will come across data sheets, but let's just recap on them on data sheets. It's allowing us to identify suitable components for circuit construction. For example, you're either being tasked to design, construct, and test a new circuit, or you're replacing a component or components in some equipment, and you need to source in, purchase, buy some new components. Now, as you know, there's a variety of suppliers. Some will just specialize in certain types of components, and some suppliers will do a cross range of electronics, electrical, and software. You could be looking at instruction manuals for electronic components, and hopefully they'll explain what the component does and how to use it. Some of these documents are written by engineers, but I can say today that I know somebody quite well who works for a big electronic company which is worldwide, based in the Northwest, and his job is solely to interpret or to change the information that the engineers and put it into user-friendly terms. Data sheets are still the best way to get information. You can get it from some of the YouTubes, but I still like to use data sheets. So we'll look at a data sheet. Now, the first page of the data sheet is basically, it tells you what the name of that component is, or that piece of equipment or circuitry or whatever it is, and basically an overview of the function. And you can find out a quick description, usually the PDFs, and it's about, you have the specification numbers and they describe what part you need. And sometimes it comes with functional block diagrams that show the internal function of the part. For example, if it was a PLC, you could have that as well within the actual PDF in the data sheet. First page will always give you the first impression. Sometimes it may not be the right one. So instead of trolling right through the data sheet, which could be up to a dozen or so pages, you look at the first page, think, yes, this is the one I need, and then you start to scroll through it to make sure that it's got exactly what you need. For example, you may need to get a capacitor of a certain value, a 25 microfarad capacitor. But what you haven't checked is the voltage, because it may be a working voltage of 100 volts, and the ones you're looking at are only 25 volts. That is just one quick example. So let's look at the data sheet. Now on the right hand side here, we can't see the writing, but that's just an example of a analog data sheet. It depends on the type of part. So some data sheets will only be a couple of sheets, maybe up to 2, maybe even be 1. But some of the more complex ones, where you're looking at heat transfers, you're looking at the logic side, and a variety of other things, it could be a dozen pages. So you want to quickly go through the early ones to see that that component is suitable for what you want to use it for. As I said, summary of the part is a summary of the part and function features. You want to find a description a bit later on, block diagrams, which I mentioned early on. And this gives you the first impression. So that is important. Now here's one here. We can see here the block diagram. And this may be where you're looking at how that component will fit in within the circuitry. A simple example is a transformer, where that transformer is powered up to a rectifier, to a regulator, and it needs to be used as part of to keep the supply. Now, depending what current ratings is, it also will depend on the type of transformer that you want to get. And also what you're going to look at is the physical side, which you're going to look at shortly. So here we have one data sheet. Now this one here will give you for an IC. So look at the pin layout. Now for this assignment, you'll only need to do for one, which is the operational amplifier side of it, which is a 8-pin dual in line. But sometimes you are looking for more complex ones, depending on the supply voltage. So it's important that you know what voltage you're working with, because sometimes the voltage that you need to power up that component, it may not be suitable for what you're doing. For example, if you want a portable piece of kit and it needs to be compact, and the actual device, the component, is maybe 12 or 24 volts, and then the suitable battery you can get is quite bulky, then it may not be suitable. So you may have to look for another component that's running between, say, 6 and 12 volts, so you can get the suitable power supply. So it's something you have to scroll through, and we do have Google now, so it does help us slim things down, and you can be looking at 1 or 2 other big search engines, which allows us to actually find that component. But like my own personal experience, that when I've been sourcing in components or kits, I've spent quite a few days at different times just looking through different information, making a note of it, and either making a note of the website or maybe printing something off and then returning back a couple of days later until eventually I can source it. If there's no finance involved in it, in other words, you have an open checkbook to spend what you like, that doesn't matter. But sometimes, you know, you've only got a limited budget to what you can spend on the certain components or the system. Now we're going to go look at here the photo of the components. So here we have a battery of some description. It will give you some basic information. It doesn't give you a lot. It'll probably just give you the code number of it, the type of battery it is, and you know, the code for the actual catalog. Now you may get limited information out of the actual catalog. So what you could also do is, if you actually put that battery number and type into Google, you may end up on the manufacturer's website, and that allows us to get you some more if you want to drill down for more information. But most suppliers will come with a PDF as well, which is probably the same as what the supplier would have on the website. Now, dimensions is very important. I've been fortunate that most times I've bought kits that it actually fitted inside the box. But if you are limited to the size of it, now remembering that what you'll be looking at in the assignment is a drone, so you don't want anything too big because it may not fit inside the actual unit, or you may be designing it from scratch, which then you can then make your own decision on the type of size you've got. But if you're actually replacing an existing battery and you can't get the exact one that originally came with the unit, and you find one similar size so it fits nicely within the unit, the last thing you want to get is one slightly too big, probably better is the exact same size or one slightly smaller with the same specification. So what happens with a lot of data sheets is you'll see what's included is the dimensions. And that is so important that the actual electronics of it may do what you want to do, but physically it won't work. It just won't sit into the compartment, into the enclosure you're using it with. So that does play an important part of it. Technical specification, which is important, and that is something you'll need to know because, for example, you can get one of these batteries, but the current rating is quite low because if it's for a drone, it's going to have a motor inside it, and it's going to be lifted off the ground. It will have to go for so long, so it's important that the current rating is spot on besides the actual voltage. So it could be a 12-volt one, but have a very low ampage on it. So it's important that you get the right one for the job. So these are things that are very, very important. Now we're going to move on to measurement systems. I'm just going to do a bit of background to it. And the reason why we're looking at measurements is quite simply is that part of the assignment, if you're working through the part where you do a simulator, which is really fairly straightforward in setting things up, or you've gone to using the breadboard and you've actually connected up all the components and you want to test it, you want to make sure that you're using the right instruments and to go about it. So we're going to look at some theory around it. So of course, measurement can take a wide and continuous range of values. It could involve temperature, pressure, velocity, meaning for the case of this assignment, you won't need to do that. But for some pieces of equipment you could be working on, you may need to do various temperature and pressure. So it's important that you have the right test equipment to measure it. So we're going to go through this little diagram about how we do the measurements, and we'll look at the physical quantities that are converted. So we're going to convert, probably in the case of what you'll be using is the electrical energy, the electrical signals, into something that can be actually measured and then converted into a unit, which we can say, yes, that is suitable for what we want to use it for. I mean, the idea is that you actually, once you've built it, you look at the actual unit itself, and if it physically does the job you want it to, that's fine. But quite often nowadays, we use the simulators at first. It saves a lot of time and a lot of wastage of components. So here we have the sort of diagram. That is what we want to measure. It is the transducer will convert it. There could be an analog variable. It goes to an amplifier. And the reason why we have the amplifier, because it could be a very, very small signal. It could be in microvolts, or it could be in microamps. And that is converted through an A to D eventually. And of course, we then look at the signal, which could be a 7-segment display. It could be on the computer, but it allows the user to see the actual measurements. So it could be measuring current, which is in amps or volts, or it could be measuring resistance, it could be measuring power, it could be measuring a lot of things. So that is just a basic, simple block diagram showing that. But in the case of this unit, you're just going to make sure that you've got the right test equipment to do the actual testing, to complete the task of the actual assignment. So in practice, so let's look at it. Now we're going to look at the physical side. We'll be looking at the virtual side in a couple of other times. What we have here, we've got the actual bench power supply. As you can see there, it's measured probably up to about 12 volts. And if the current starts going up, we've got an inbuilt ammeter there. That is so convenient. As long as it's calibrated, it just means to say that you put a circuit board under test across the supply, and all of a sudden the ammeter shoots right across, and you know that they should be drawing that current, so you immediately switch off. So that has both measures. That will also allow us to look at the voltage that we set it, and we can also look at the current drawn from the supply into the board. At the top here, we've got here a dual beam oscilloscope. It does have a storage mechanism, and what we can see is a square wave on one of the inputs. Here below it, we have known as a portable multimeter. The reason why we call this portable is this is one that engineers, service people, or people that need to move their multimeter from one position to another. We'll be looking at another type very shortly. So what we have to the right here is a function generator, and this device here would allow us to produce various AC or square wave or triangle signals, anything from about 50 hertz up to probably about 100 kilohertz. And to our right, we've got here is a bench multimeter. Now, I like these bench multimeters because what we've got on this one is not only does it do the voltage, but also up to a certain frequency, you can measure frequency, current, and even measure the value of resistance and capacitance. So it's a very, very versatile. And if you open up that lid at the top there, you can insert some batteries. So you can convert this into a portable bench multimeter, and it's pretty good. Very well. I bought this one a couple of years ago. These are on my personal kit, but it's all industrial standard. At the bottom here, this is a logic probe, which we'll be looking at later presentations. And beneath it, we can't see it working, but beneath there is a very simple portable single beam oscilloscope, which we'll be looking at a later date. Okay, now it's important that when you are writing your assignment, and I will mention this later on the slides, that everything's annotated. Here we've got DC variable supply, portable voltmeter, we've got the function generator, a bench multimeter, and here a logic probe. And it really is, it makes that piece of work, that assignment, a very professional piece of work. Now we're moving on to simulators. Now this is just one example of a simulator here. We'll look into it in a bit more detail. What happens is that with the simulator, you build a circuit. And in the case of yours, you'll have the LEDs built into well, and hopefully what you should get is a waveform. The reason why it starts like that is because the software doesn't start immediately, like on a hardware where we connect it to an oscilloscope. You immediately see that signal produced from zero, where here it takes a couple of milliseconds to start up, and that's why we see this little line before it comes on to the triangle waveform. So here's a Tina one, this one here with a waveform. So when you set it up, if you want to use Tina to prove the circuit, then you can use that. Now I would suggest and recommend that you build a circuit on the simulator, and then you can then prove it if you're going for the higher grade onto the breadboard. This is the one that I'm quite keen to use, which is the Circuit Lab one here. Here we're looking at two signals. We've got at one point we can see a square wave, and the other output we can see the triangle wave as well. And it tells you which chip you're using as well for this one. I'd also recommend that you use the European standard resistors. This is the American version. You just do a right and click on the components, and it lets you set up for the European standards. And this is using a triple timer and just a basic simple oscillator. Now, back to the actual breadboard building. So if you are working on the higher grade, just some hints and tips, which we will cover a bit later on within this presentation. What you want to make sure is that you've got a nice clear view of the actual circuit built on breadboard. You want to ensure that the wires are neatly connected up. I mean, what I would do is just, connect it all together, make sure it works. Once you know it's working, then just each wire, just cut it and neatly put it in. It's a bit messy, but it's not bad. We can see it. The only thing we can't see is the waveform on here, because we need to look at it fairly close. So what there is there, we're looking at this triangle waveform, which is the part of the circuitry which is allowing it to actually flash. So that's a waveform trace. Now, as I said from an earlier presentation, insert the IC first and build the circuit around it. Before you power up, recheck the constructed circuit. I will check it a few times. and ensure that when you power up, as long as you've only got a few milliamps from the power supply. If you don't have a posh power supply that I showed earlier on, then just connect up a multimeter in series on milliamps in series with a supply to your battery or your DC supply to see if the current is not too high. Important is positive and negative. Make sure that the polarities that the battery using or the bench supply, you've connected it correctly, because these ICs are not forgiven. The resistors, the capacitors are not a problem, but these chips, 741s, they're not forgiving and they will blow up if you have a reverse polarity. Okay, so we've reached, well, probably more than halfway. We're just going to go through some of the areas within the assignment, just to give you some hints and tips so that you're ready and prepared to complete it. So we'll look at the first question. And the first question, you're going to choose a battery, basically, for a drone. So if you think about it, you don't want to get a massive car battery inside it because it's going to be too big and too heavy. You are given a sort of specification within the actual assignment. A minimum voltage of 12 volts, 3000 milliamps per hour, maximum current of 40 amps. Now 40 amps is quite a lot, and to find one, you're just going to have to sort of do some careful research, but they are around. Now you don't have to be exact, as long as you're near enough it, then you should be okay. As I say, through your specifications laid out in the assignment, look at electronic distributors that are online. There's one about 4 I can think of hand. You can go on to further reading and look at some of the stuff on Amazon as well, but ideally look at some of the UK electrical distributors and identify a suitable battery. So what you need to do with that is show examples, make sure that the battery, the specification is annotated. And what I mean by the annotation is where you got key points within that specification. In other words, the voltage, the capacity for the current, minimum max, and the weight, those need to be identified within your evidence when you include it. Don't just write it out, show it on the data sheet, annotate it. So there are some examples. You can see a top here, the battery. This is a general overview of the specification, and there's some more information as well. But don't make it thumbnail, make it large, proud, not the actual physical battery, but more the specification. And what I would do is, ideally, print it off, or if you can annotate it on the screen, annotate it so you can make the reader, i.e. myself, be able to see it, so I know that you are going for the right actual battery. So what we're going to look at next is the actual simulation. Now, even if I wasn't doing an assignment and you were building it for your own company or as a hobbyist, it's probably easier to actually simulate the circuit. Now, this is not the exact same one. This has got some resistors in it, so you have to look at the circuit you've got. You may want to make some changes to improve on it, but you also want to make sure that you can test it and look at the actual frequency. And what is important is by using one of the simulators, you should hopefully quickly see what within the simulation what the frequency is. But please note that is when you build it on Breadboard, this is giving you what is probably a textbook reading. So in other words, the resistors and the capacitor has no tolerance. It's just 30 microfarad or 10K, where on your actual physical one, you may have tolerances up to plus or minus 10%. And the fact that you may have some resistance in the wires. So as long as you get a similar result, it shouldn't be too bad. So what is important is before photographing is you need to set out the practical evidence neatly. In other words, a board is set out. Here's an example. We've got the breadboard here at the bottom. We've got a function generator in this case, and oscilloscope. Now, this is just an example. This is not the one you're building, but all you will need for your circuitry for doing it is a power supply, which could be a battery or a bench supply, and a scope. Now, you may decide to invest in your own, so you can use a single beam one. You can get these small portable ones from the Far East, which are under £30. They are quite accurate. And what you also need to do is when you photograph it, don't just stick the photograph on its own, annotate and see where you can annotate the components. So there's a function generator, there's the oscilloscope, and there's a breadboard. And that's an example of a photograph. So what you want to do underneath that example is an explanation on a bit about the circuit and what you've done. And if for some reason the circuit is not functioning as well as it should be, importantly, you need to make sure that you actually explain what's going on, because that will also be to your advantage when you're trying to go for higher grades. Now, with this one here, we've got this circuitry built on breadboard, but what's happened here, it's been labeled up. So what happens is everything around it has been ignored, or should we say just photograph the actual breadboard and the components and identify them. So you don't have to do hundreds of photographs, as long as you've got, say, two or three, maybe four, and different angles, which we'll look at very shortly. So the photographs, especially for the higher grade one, is very important. And I would suggest you take different photographs. Now, what I've done here is I've just taken the photograph, but what you'll need to include is annotations on each one. So we've got the breadboard look at the side, that's a top view, and that's an idea of looking at the bench. This is another board, but this is an example of looking at the instruments. So you can take it separately, as long as we can see the waveforms, and possibly if you want to connect up a multimeter just to show the voltage of what's going into the flashing unit. I'm going to take the photographs. I'm going to say here's another picture showing everything there, and you may have your little breadboard in the center here. But you know, once you've got a nice photograph and you can just annotate it, you can put it in the color that you can let the reader see, and you can tell you're making that piece of work look more professional, and that should hopefully give you the right grading for it as well, if it looks quite good. You can, and I don't have an issue if you want to handwrite over each of these, so you want to do it that way. But the saying goes, because it's your own photograph and you're photographing your own kit, then using a typed up version, there'll be no problems. So what we're looking at is for this time, research various batteries suitable for drones and using the various online distributors and to identify suitable one. Annotate all your photographs and screenshots, include explanations on the suitability of the battery. For your practical built drone flashing unit, photograph the actual board, construction, including all the test instruments. And you must say that Harvey referencing for any information that you've researched via the internet or any textbooks for that matter. And then sure that your assignment is written up. The only thing which I think will be okay is that you can handwrite the annotations on the photographs. That is not a problem. And finally is, don't forget, is we've got these new assignments now. It will tell you the word count as well, and make sure that they are typed up and they are then put into a PDF and then uploaded onto Moodle, and you shouldn't have a problem.